So this will be our next lesson in Chapter 7 for Algebra 1. This could be Lesson 7-2. So just make sure you add these to your notebooks. We've been talking about properties and laws of exponents. We're going to continue here with that and then work our way to radical expressions or rational expressions. So here today we're going to look at division properties of exponents. And here what we're talking about when we have exponents, so when dividing powers with the same base, subtract exponents. So whenever we have something like this, x to the third over x to the second, we just subtract the bottom exponent from the top. So here we just take x, 3 minus 2, and then we get x to the first power. That's kind of how we do that. So if we had another one, for example, let's say we had x to the fifth, x to the third, we would just take it x to the fifth minus the third, and that would be x to the second. Okay. So that's kind of how you do that. Pretty simple rule. Just subtract exponents and when you're dividing. So then we have something else called the zero exponent property. This is saying instead of having a number, you have a zero as your exponent. And this just says any non-zero number raised to the 0 power is equal to 1. So no matter what we have here, 15 to the 0 power is 1, x to the 0 power is 1. The only little limitation we might have would be 7 times x to the 0. X to the 0 would then be 1. 7 times 1 would be 7. So that's kind of your zero exponent property. And then we have a couple more. We have one called the negative exponent property. And this says negative exponents will form inverses. So here we have something like 2 to the negative fourth. And what that's really telling us is 2 to the negative fourth is then going to be an inverse of 2 to the fourth. So we're just going to put this into fraction form and say 1 over 2 to the fourth. And then we can just do the 2 to the fourth, and that would be 1 over 16. So it's a fraction is what we're looking at. If we had something a little bit different, if we had 1, already had a fraction, 1 over j to the negative fourth, this would then be the inverse, which would be j to the fourth. Okay, that's a couple examples there of the negative exponent property. You're just going to do inverses. And then when we have something called the power of a quotient. So let's say we have this like a fraction, and we have it raised to a power here. So here we have 3p to the third divided by 7. Okay. And the rule here says to find the power of a quotient, find the power of the numerator and the denominator separately. So here we have 3p to the third over 7, and that's to the second power. So we just use the rules, we do one at a time. So 3 squared is going to be 9. And then this is going to be, we just follow the rule for powers in exponents, and we're just going to multiply. So that's going to be p to the sixth. And then here we're going to take this second to the second power and do it for 7. So 7 times 7 is 49. And that's our answer using, or how we do power of a quotient. So if we keep going, let's just do a couple examples here and then we'll be done for the notes. These should be pretty short. Okay, so here we have some division. We're just going to do one at a time. And so we look at this one, x to the third over x squared, or x cubed this can also be called. So then we just take 3 minus 2, that's going to give us x to the first, and we won't even write we won't write the first. Okay, then here we have y to the fourth, and this is y to the first, so it's going to be 4 minus 1, and that's going to be y to the third. So simplified, that's what we have there. We have another one here, so we have k to the seventh times m to the 10th times p over k to the fifth, m to the third times p. So here we're going to have 7th minus 5, so we're going to get k to the second. Next one, we're going to have 10 minus 3 for the m, so we're going to have m to the 7th. And then we're going to have 1 minus 1, so because these are both 1s, it's going to be p to the 0 or 1, so we don't even have to state it, it's just 1 anyway. So k to the second, m to the 7th. That's an example, a few examples of doing division. And then if we just look at negative exponents here, and we want to simplify. So if we're looking at this one, so we'll just see what we have first. Let's just name off what we have. So n to the negative fifth times p to the fourth and r to the negative second. So these are going to kind of switch, the n and the r, because this is really like saying 1 over n to the fifth. So, and then the r to the negative 2 is going to be the inverse. So we're going to have r to the second, p to the fourth, over n to the fifth. That's what that ends up being. We just switch these around with their inverses. Okay, the next one, simplify this one. So we're going to worry about the numbers last. Okay, here we have r to the first, r to the second. So this is going to be, you might have to rewrite this. So maybe we'll just do this now. So 5, this is going to cancel. It's going to be 1. We won't even write it. And then this is going to be negative 4 for the number. So negative 4. And then we're going to look at the r to the negative 3. So that's going to be r to the third on the bottom, right? And then we're going to have the exponents r to the third and r to the second. So we're going to have r to the fifth. And then we have t to the fourth. We're going to minus the 7 here, right? So that's going to give us t to the negative third. So we're going to want to put that on the bottom, because we'll just use the inverse. And then we're going to have u to the negative 5. So on top, we're going to have u to the 5 and use that. Put the inverse of that up there. So in the end, we should have u to the fifth over negative 4r to the fifth times t to the third. So that's our negative exponent simplification. And then, if we look at these power of a quotient, let's simplify these guys. Again, we're just going to take this power, and we're going to do whatever we have to that one, and then that one. So here we have 3 to the third power. So 3 times 3 is 9, times 3 is 27. And then here we have, we're going to follow the rule, so we have x to the fourth. We're just going to multiply these. That's going to be x to the 12th. And then here we have 4 to the third power, so 16. It's going to be 64. And I'm not going to worry too much about whether that can be reduced or not. I don't think it can be. And then, so that's the answer for that. And then here we have the 3, this power here. We're just going to distribute it to the top one and then to the bottom one. So we'll do the numbers first. 4 to the third is going to be 64. And then x to the third, we're going to multiply these together. They're going to be x to the ninth. And then here again, 5 to the third is going to be 25. It's going to be 125. It's going to be 5 times 5 is 25, times 5 is 125. And then y to the fourth times 3 is going to be y to the 12th. Okay, and that's our simplification of that. So those are our examples of each of the types of division, negative exponents, and zero property. If you have any questions, let me know in class. Add these to your notebook, and see you in class.